Welcome back to part 2 of discoveries from the Ghana building code that can literally save you tons of money and prevent your building from structurally failing, and then ultimately prevent danger for occupants of your building. So let's get straight to it. The first point is about illegal extensions. An example is having a balcony when it's not originally supposed to be there, or adding extra weight and load to that balcony. Another one is extending your building past the number of floors that it was originally designed and built to handle. Now, the building code specifies that extra load or dead loads must be strictly certified by a structural engineer, because overloading actually leads to sudden collapses. So whenever you make any change at a balcony, create an extra space, add an extra floor, you must always hire a structural engineer to do some non-destructive test. They call it NDT. And it can really be simple. They can do simple things like using a Schmidt hammer to test the strength of your existing concrete and doing other checks. But it's really important, and it's ultimately much cheaper than dealing with a total collapse. Now, the next point is what I would term the sick building syndrome, which section 23 mentions relating to ventilation and air quality. The code requires specific air changes per hour. Now, the challenge is a lot of buildings in Ghana have only one window, so no cross ventilation, or certain rooms have tiny 20 by 20 centimeter vents which actually do not move air at all. Now, we may think, oh, this is trivial, but there's a danger to it, because the high humidity, especially in places like the bathroom, can lead to black mold behind wardrobes and causes breathing and respiratory issues, which a lot of people attribute to malaria or allergies, but that's not actually the case. So practical fixes for this, if you've already built your building, of course, you can install mechanical extractor fans as an example, but if you can't afford it, you can install passive vents like louvered bricks above your doors, which will allow air to circulate even when the door is closed and prevent mold and other things. So by all means, find ways to ensure that there is some vent for air to circulate all the time. The final one I'll give is something I would term the pancake collapse issue, where your roof can fall straight down to the floor below. This can happen when the house is finished, would put 200-liter poly tank on the roof, which was not previously part of the plan. Now, if you do the math, right, 200 liters of water weighs about 200 kilograms, and that is the weight of having two small SUVs sitting on top of your roof. So if your pillars were not originally built for this, you would cause a collapse. If you have tank on top of your roof and you see maybe some cracks somewhere along where the wall meets the ceiling, you know that you are about to experience this. So you have to drain it immediately and move the tank to a standalone steel concrete or something on the ground, right? And use some small pump to push the water up. You could use a very small tank just to contain the water up there, but don't actually use this 200-liter tank to be the primary source of water and leave it on top of the roof. Alright, so we'll pause here, at least with these points from part 1 and part 2. Be the primary inspector of your building. Go check it out. Make sure that these basic things are not being violated. So thank you for sticking around, and see you in the next video.